Here we have another interesting problem. The transformation represented by the matrix T equals C0, 0D, maps the point 4, 5 to 4, -5. Find the values of C and D. Let's pause here. So this matrix T, let's pause here. Let's not go any further. So T, it maps 4, 5. So in other words, if I multiply this matrix by 4, 5, I expect to get what? Correct, 4, -5. So this matrix, it maps 4, 5 onto 4, -5. So if we multiply it by 4, 5, we get 4, -5. Let's do the multiplication now. So row by column, so you apply C0 to 4, 5. And you'll end up with what now? C0, you apply C0 to 4, 5. So C times 4 is 4C. And 0 times 5 is 0, alright? So it's just 4C. Then let's do the second row, which is 0D times 4, 5. So 0 times 4 is 0. And D times 5, so that's 5D. Equal to 4 minus 5. So we can see what's happening here now. So 4C equal to 4. Divide both sides by 4, C equal to 1. And 5D equal to minus 5. Divide both sides by 5. D equal to minus 5 over 5, and that's minus 1. Good? So the value of C, so let me just write, so therefore it means that T is therefore, it means therefore that T is C0, and we know C is 1, so 1, 0, and D is -1, so 0, -1. So that's our matrix T. Now we are asked to find, okay, no, describe the transformation fully. Describe the transformation fully. Now you will know that any transformation, notice what happened with this coordinates here. So 4, 5 becomes 4, -5. So notice what happened here? What happened here? The y coordinate changes. What type of transformation does that? Yes, you're correct. It's a reflection in the x-axis. Alright? So this represents a x-axis, a reflection in the x-axis. Alright? Remember, so the coordinate setup is the x-axis, is the y-axis. If you have any point, this point is about 4 or 5, so we're somewhere about here, 4 or 5. If you reflect a coordinate in the x-axis, it will come over here, notice, and then note, you see what happened. Over here the y is positive, over here the y is positive, and down here the y is negative. So if you have a point up here, say 4 or 5, and you reflect this point in the x-axis, what will happen is that it will come over here through the mirror line. If you reflect over here, and the x coordinate will remain unchanged, but the y coordinate now will become negative. Alright? So that's what's happening there, x-axis reflection. Well, that's the description of the transformation. And we're asked now to find the matrix Q that represents the point Q okay. So question here was, so Mr. Rodin, the question should read, find the matrix Q that maps the point Q. Find the matrix. The matrix is not Q. This question should find the matrix. Alright, so find the matrix that maps the point, because the point Q and matrix Q can't be the same thing, can it? So find the matrix that maps the point Q back to P. So again, so a matrix T maps 4, 5 to 4, -5. So they're asking, which matrix maps back 4, -5 to 4, 5? Which matrix do you think? Certainly. It's the same axis, x-axis reflection. So here's a point P, here's a point Q. If you reflect P in the x-axis, you get Q. And if you reflect it back again, going back to P over there, alright? But anyway, so we can always use the inverse to prove that, right? So T maps P to Q. So which matrix will do the reverse? The inverse matrix do the opposite, right? So let's find the inverse of this matrix, T. And 1 over determinant, what's the determinant? We find the determinant, the cross multiply and subtract. Alright, so 1 over, so minus 1. The determinant is minus 1. So 1 over minus 1, which is minus 1, right? And then what will happen here now? The aggregate is that these elements will change positions. So minus 1 come here, and 1 come here. And then these supposed to change signs, but 0 has no sign, right? So there's still 0. So we have negative 1 outside. If we expand the bracket now by negative 1, negative 1 times negative 1, that's positive 1. And times 0 is 0. And negative 1 times 1 is negative 1. Notice you get back the same, because obviously this represents a reflection in the x-axis. So you expect to get the same thing. Alright, so T inverse is the same thing as T. Alright, which makes perfect sense. Because if you reflect a point in the x-axis, it come over here, so. And if you reflect back the same point, the image point, in the x-axis again, it jump back over here, so back to the original location. So it makes perfect sense. Okay? Next we look at solving simultaneous equations using the matrix method.